Hello everyone, and welcome to this channel once again. Let's read through the following question. What is the most important assumption to reduce the Navier-Stokes equation to boundary layer equation? Once again, what is the most important assumption to reduce the Navier-Stokes equation into boundary layer equation? Today we have another knowledge or theoretical based question bordering Navier-Stokes equation and how it can be reduced to boundary layer equation, or how we can derive boundary layer equation. But in this question, we are asked to find out or state out the most important assumption to reduce the Navier-Stokes equation to boundary layer equation. First of all, the most important assumption to reduce Navier-Stokes equation into boundary layer equation is the assumption of the boundary layer approximation. That is to say, the boundary layer approximation assumes that the flow field can be divided into two distinct regions: the thin boundary layer region near the surface and the outer region away from the surface. This assumption is based on the observation that in many practical cases, the boundary layer is much thinner compared to the overall flow domain, and the flow property within the boundary layers are significantly different from those in the outer flow region. So under the boundary layer approximation, the following key assumptions are made. So the first assumption is that in the thin boundary layer assumption, the boundary layer is assumed to have a small thickness compared to the characteristic length scale of the overall flow field. This allows for the simplification of the equation by neglecting all the variation in the flow property across the boundary layer thickness. Number two, negligible pressure gradient in the boundary layer. It is assumed that the pressure gradient in the direction normal to the surface is negligible within the boundary layer. This assumption allows for the neglect of the pressure gradient terms in the boundary layer equations. 3. Steady state and incompressible flow. The boundary layer is assumed to be steady state, meaning that the flow property do not change with time. Additionally, the flow is assumed to be incompressible, which simplifies the equation by removing the need to consider the compressibility effect. 4. The viscous effect dominates the effect of viscosity, are assumed to be dominant in the boundary layer compared to the other forces, such as inertia. This allows for simplification of Navier-Stokes equation by neglecting certain terms that are negligible in the boundary layer. By making all these assumptions, the full Navier-Stokes equation can be simplified into a set of boundary layer equations, such as boundary layer momentum equation or the boundary layer energy equation. This equation could describe the flow behavior specifically within the boundary layer and are more amenable to analytical, numerical, and practical engineering application. So therefore, from the following question, we can deduce that the first assumption is that the boundary layer is assumed to have a small thickness. Number one, the boundary layer is assumed to have small thickness. Number 2, the pressure gradient in the boundary layer is negligible. Number 3, the flow in the boundary layer is assumed to be incompressible. And steady. Number 4, the viscous effect in the boundary layer dominates the inertia forces in the fluid flow. So therefore, we have 1, the boundary layer is assumed to have small thickness. 2, the pressure gradient in boundary layer is negligible. 3, the flow in the body layer is assumed to be incompressible and steady. 4, the viscous effect in the body layer dominates the inertial forces in the body layer. From this, we can deduce that from the Navier-Stokes equation, which is u du dx plus v du dy, which equals -1 over pressure dp dx plus mu d square u rho dy squared can be reduced to boundary layer equation, which is du dx plus dv dy, which is 0. Thank you for staying tuned.